Good morning. I am Regina, Assistant Professor, Rohini College of Engineering and Technology, Department of Mathematics. Today I am going to teach reduce quadratic form into canonical form by orthogonal transformation. Course outcome. After completing the course, the students are able to apply the concept of orthogonal transformation to diagonalize the given matrix. Reduce the quadratic form x1 square plus 2x2 square plus x3 square minus 2x1 x2 plus 2x2 x3 plus 6x2 x3 into canonical form through an orthogonal transformation. Also find the nature, rank, index and signature. First you have to change this quadratic form into matrix form. The formula is coefficient of x1 square half into coefficient of x1 x2 half into coefficient of x1 x3 half into coefficient of x1 x2 coefficient of x2 square half into coefficient of x2 x3 half into coefficient of x1 x3 half into coefficient of x2 x3 coefficient of x3 square. So here coefficient of x1 square is 1, so write here 1. The coefficient of x1 x2 is minus 2, so half into coefficient of x1 x2 is minus 1. Next coefficient of half into coefficient of x1 x3, there is no x1 x3 term, so we have to put here 0. The next half into coefficient of x1 x2 coefficient is minus 2. Half into coefficient means minus 2 by 2, the answer is minus 1. Coefficient of x2 square is 2, write here 2. Then half into coefficient of x2 x3 coefficient is 2, we have to divide this by 2, so answer is 1. The next half into coefficient of x1 x3 coefficient is, there is no x1 x3 coefficient, so here put 0. The next half into coefficient of x2 x3 coefficient is 2, so divide by 2 and write here 1. Coefficient of x3 square coefficient is 1. Okay. The next, the characteristic equation is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. So here we have to find s1, s2 and s3. First find s1. S1 is sum of the main diagonal elements. Some main diagonal element is 1, 2, 1. So we have to add this 3, the right 1 plus 2 plus 1. So the answer is 4. So next to find S2, sum of the minus of the main diagonal element. S2 is, the minus means first take the diagonal element 1, take the minor of this 1, reduce the row and column, the corresponding row and column, the remaining term is 2, 1, 1, 1. So find the minus of 2, 1, 1, 1. Okay. The next find the minus of this 2. So remove this row and column, corresponding row and column, we get 1, 0, 0, 1. 1, 0, 0, 1 plus take the minor of this 1. So remove the row and column, we get 1, minus 1, 2. So we can get 1, minus 1, 2. We have to solve this. 2, 1, 1, 1. So we have to solve this 2 minus 1. 2 minus 1 is 1. Here 1 into 1 minus 0. So 1. Here 1 into 2 minus 1 into minus 1. So 2 minus 1, 1. So we have to add finally 1 plus 1 plus 1. The answer is 3. The next find the determinant of the matrix A, that is S3. So determinant of this one. So 1 into, remove this one, corresponding column and row, we get 2 into 1 minus 1. So 1 into 2 minus 1 minus, for this one we have to put plus, here minus, here plus. So 1 into 2 minus 1 minus of this minus 1. So plus 1 into minus 1 minus 0, minus 1 minus 0 plus 0 into, so the total value is 0. Here 2 minus 1 is 1 minus 1. So the answer is 0. So the determinant value, that means the S3 value is 0. So next we have to apply S1, S2, S3 in the characteristic equation. We get lambda cube minus 4 lambda square plus 3 lambda equal to 0. So we have to solve and find the lambda values. So here lambda is common, so we can take it outside. After taking the lambda outside, we get lambda into lambda square minus 4 lambda plus 3 equal to 0. So lambda equal to 0 and lambda square minus 4 lambda plus 3 equal to 0. It is a quadratic equation. We have to solve this. Multiplication 3 and addition minus 4, we get 1 and 3 lambda values. So finally the lambda values are 0, 1 and 3. So next we have to find the eigenvectors for this corresponding eigenvalues 0, 1 and 3. So next we have to substitute lambda equal to 0 in the equation a minus lambda I into x equal to 0. So a minus lambda into I value is this one, 1 minus 1 0 minus 1 2 1 0 1 1. That value into x1 x2 x3 is equal to 0 means we have to write the 0 in matrix form 0 0 0. So we have to write 3 equations from this. So x1 minus x2 plus 0 x3 equal to 0. Next minus x1 plus 2x2 plus x3 equal to 0. 0 x1 plus x2 plus x3 equal to 0. So next we have to solve 2 distinct equations from this and solve by cross multiplication rule. So here we have to solve equation 1 and 2. So first we have to write the coefficient of x1, that is 1, coefficient of x2, that is minus 1, coefficient of x3, that is 0. Once again we have to write this 1, minus 1, 0. The next write the coefficient of the second equation, coefficient of x1, x2, x3, minus 1, 2, 1, minus 1, 2, 1. So we can get x1, x2, x3 values. x1, x2, x3 values. x1 divided by minus 1 minus 0, x2 by 0 minus 1, x3 by 2 minus 1. We get x1 by minus 1, x2 by minus 1, x3 by 2 minus 1. So finally the capital X1, the corresponding eigenvector for lambda equal to 0 is minus 1, minus 1, 1. The next we have to find the eigenvector for lambda equal to 3. So we have to apply this lambda in this diagonal element 1 minus 3. This is the given matrix A minus lambda I means we have to subtract this 3 for the diagonal elements only. Minus 3, minus 3, minus 3. We get the equation minus 2, minus 1, 0. So we have to multiply by this row, this column x1, x2, x3. So minus 2 x1 minus x2 plus 0 x3 equal to 0. Minus x1 minus x2 plus x3 equal to 0. 0 x1 plus x2 minus 2 x3 equal to 0. Like the previous one, we have to solve equation, any 2 distinct equation we have to solve. Here we have to take 4 and 5, use cross multiplication rule. We have to get this one, x1 by minus 1, x2 by 2, x3 by 2 minus 1. So we get this one. So capital X2 is minus 1, 2, 1. So like the same way we have to find the eigenvector for the lambda value 1. Here we have to subtract this 1 in the diagonal element. So this is the given matrix A minus this lambda, minus 1, minus 1, minus 1. We can get 3 equations, 0 x1 minus x2 plus 0 x3 equal to 0, minus x1 plus x2 plus x3 equal to 0, 0 x1 plus x2 plus 0 x3 equal to 0. We have to solve any 2 distinct equations. Here we can take equation 7 and 8. By cross multiplication rule we can solve this. We get x1 by minus 1 minus 0, x2 by 0 minus 0, x3 by 0 minus 1. So we get this one. So capital X3 value is 1, 0, 1. So hence the corresponding eigenvectors are capital X1, capital X2 and capital X3. So next we have to check for orthogonal, capital X1, capital X2, capital X3. So we have to multiply X1 transpose and X2. This is X1 transpose. Transpose means we have to, this X1 is a row column matrix, we have to change this into row matrix. So 1 minus 1. So capital X2, we have to multiply 1 into minus 1 minus 1. 1 into 2, 2, minus 1 into 1, minus 1. So the answer is 0. If you get 0, this x1 and x2 are orthogonal. So like the previous one, we have to multiply x2, we have to verify for x2, x3 and x1, x3. So here x2 transpose into x3. x2 transpose into x3. x2 transpose into x3 minus 1 into 1, 2 into 0, 1 into 1. So the answer is 0. So x1 and x2 and x3 are orthogonal. Here x3 transpose and x1, we have to multiply 1, 0, 1, 1, 1, minus 1. 1 into 1, 1, 0 into 1, 0, 1 into minus 1. So we get 0. So here x1, x2, x3 are orthogonal. Normalized eigenvectors are. So we have to write this matrix x1 values divided by square root of So this is the x1 value. We have to divide each element by square root of sum of the square of this element. Sum of the square means 1 square plus 1 square plus minus 1 square. So the value is root 3. Here square root of 1 square plus 2 square plus 1, root 6. Here 1 square plus 0 square plus 1. So the value is 2. We have to divide each element by this root 3. 1 by root 3, 1 by root 3 minus 1 by root 3. Here we have to divide root 6 by each element. Here we have to divide root 2 by each element. So we get this one. This is the normalized eigenvectors. So next we have to write the normalized model matrix. So we have to collect all the three normalized matrix. This is the normalized model matrix. We have to find n transpose. N transpose means we have to change this rows and into column. So we have to write this, take this column and write here this column into row. Here also write this column and write in row. Take this column, write in row. This is n transpose. So next we have to find the diagonal matrix. Diagonal matrix is n transpose an. This is n transpose. A is the given matrix. N is this one. We have to multiply these three matrix. After multiplying this, we get this 0, 0, 0, 0, 1, 0, 0, 0, 3. This is the diagonalized matrix. We get the eigenvalues in the diagonal elements. Here our lambda value is 0, 1, 3. We get this value here. So next we have to find the canonical form y transpose dy, where y is equal to y1, y2, y3. So y transpose is this one, D is the diagonal matrix, this is capital Y. After multiplying this, we get 0 y1 square plus y2 square plus 3 y3 square. So here rank is the non-zero eigenvalues. The non-zero eigenvalues is 1 and 3. Index is non-negative eigenvalues, that's also 2. So non-negative means 1 and 3. Signature is 2p. This is rank is R, index is P, signature is S. S is equal to 2p minus R. 2p minus R. That is equal to 2 into 2 minus 2. So 4 minus 2 is equal to 2. So the signature is 2. So nature is positive semi-definite. Nature means if all the eigenvalues are positive, means that is positive definite. Any one 0 and the remaining positive means that is positive semi-definite. Here the nature is positive semi-definite. Some important topics from this topic. Thank you.